Let's quickly discuss data transfer rates for RAM. Now, on the left here, we have a CPU, and the CPU relies on cache memory internally to store the most commonly used instruction sets. But the cache memory is very limited. So, all the other data needs to be stored for this current session on RAM. Because there's so much data during a computer session, we need to make sure that the RAM is fast and can transfer a lot of data per second. How do we find that out? Well, let's give an example here. And we'll say that this is a DDR4 memory module, and the type is DDR4 2133. Now, some people will refer to this as 2133 megahertz, but really what this means is 2133 mega transfers. It can do 2133 mega transfers, or millions of transfers per second. Now, how do we figure out exactly what the data transfer rate is from the memory to the CPU? Well, we have to think a little bit here, and we have to say, okay, the RAM needs to communicate with the CPU, and it does that by way of the address bus, and that is a 64-bit bus. 64 bits. Now, what does that mean? Let's go down to our little calculation area down here. 64 bits means that there's actually 64 circuits, and we can send 64 bits of data simultaneously per cycle. Now, if we want to figure out the amount of actual data that we can transfer, we want to calculate for bytes. So 64 bits actually equals 8 bytes, because there's 8 bits per byte. So 64 bits equals 8 bytes. Every cycle, we're sending 8 bytes of data. And there's a ton of cycles. How many? 2133 mega cycles, basically. So what are we talking about here? Well, we want to find out the maximum data transfer rate and solve for bytes. So we could do that by taking this number here, 2133, and multiplying by 8, by the amount of bytes that are sent per cycle. That's it. So let's bring over our trusty calculator and do the math. If we do 2133 times 8, we'll get 17,064. But really, it's a little higher than that. It's 17,066. Let me redo the calculation a little bit more accurately. 2133.33, because this is really a repeating decimal. So it's 2133.33, and the threes keep going. It's okay to just stop at 2 decimal points, though. So we'd say 2133.33 times 8, and that'll give us 17,066, and really the answer would be 0.6666 repeating decimal. But this is good enough for me. 17,066. But how much are we talking about here? Remember that we're talking about mega transfers. So really, it's 17,066 megabytes per second. So the total data transfer rate is going to equal 17,066 megabytes per second. That's how much data we can transfer back and forth between the RAM and the memory controller that's part of the CPU. 17,066 megabytes per second. That's what this particular RAM can do. Other types of RAM with higher mega transfers per second will send more megabytes per second, but basically all you're doing is using the same equation. You'll say mega transfers per second times 8 and solve for bytes. So that'll equal the amount of megabytes per second. And that's it. That'll be your equation, regardless of what DDR4 or 5 or whatever you're using. Now, this name here, DDR4-2133, that's the DDR4 standard, but it will correspond to a module name quite often. And that name will be based off of the amount of megabytes per second. So, for example, this module standard is DDR4-2133, but the module name would be PC4-17,000. And you might see it read as 17,066 also. That would be the actual module name for this RAM. So there's a little data transfer rate calculation for DDR4.